Hey there, it's Shannon MATHCHICK Myers, and today we're on part 3 of using partial fraction decomposition on integrands in order for us to be able to evaluate the integral or find the indefinite integral. So here we go. We're looking at the case where Q contains, the denominator contains a non-repeated irreducible, that's important, quadratic factor. So if Q contains a non-repeated irreducible quadratic factor of the form ax squared plus bx plus c, then in the partial fraction decomposition of p over q, allow for the term p at x over q at x, or whatever your, variable is, will equal to a sub 1x plus b1 over ax squared plus bx plus c. That's unable to be factored, remember, where the numbers a1 and b1 are to be determined. All right? So in example 3, make sure that you watched the first part, because that's where we went over non-repeated linear factors, because this one does factor. It's a difference of cubes, is it not? So this is equivalent to the integral of 6x over x minus 2 times x squared plus 2x plus 4 times dx, all right, or with respect to x. Now let's see what we get. So we have 6x over those two factors, so our partial fraction decomposition will be 6x over x minus 2 times x squared plus 2x plus 4 equals. So for the first one, I'm just going to put a regular a with no subscript. So a with no subscript over x minus 2, because x minus 2 is a non-repeated linear factor. Now, the next one, we'll use the a1x plus b1 because x squared plus 2x plus 4 is an irreducible quadratic factor. Good so far? Awesome sauce. So now, getting a common denominator on the right side, so I need to multiply my a by x squared plus 2x plus 4, and then multiply my a1x plus b1 must be multiplied by x minus 2 in order for us to have that common denominator we're looking for, which is x minus 2 times x squared plus 2x plus 4. Groovy? Now that we have our common denominator, we can let our numerator, we just work on equating the numerators. So we have ax squared plus 2ax plus 4a, and then plus a1x squared minus 2a1x plus b1x minus 2b1. And then we will have 6x equals. There are 2x squared terms, so we'll have a plus a1 times x squared. And then we have 3x terms. So the x terms are 2a minus 2a sub 1 plus b1. All of that is times x. And then we have two constant terms, which are 4a and then minus 2b1. Cool so far? Now, let's see. We have a 0 for our constant terms, and we have a 0x squared that we can add in. And then we'll be equating the 0 for the coefficient of the x squared to the a plus a sub 1 on the right-hand side. And so we'll have a plus a sub 1 is 0. Next up, we can equate the coefficient to the x on the left is 6, and on the right side it's 2a minus 2a1 plus b1. So we'll have 2a minus 2a1 plus b1 equals 6. And then continuing, we have 0 is the constant term on the left, and 4a minus 2b1 is the constant term on the right. So we'll have 4a minus 2b1 is equal to 0. Cool so far? Okay, so I'm looking at this system, and I think that if I need to isolate a1 and write it in terms of a. So a1 equals negative a, because I'm looking at the middle equation. And then when I look at the third equation, I need to isolate b1. So negative 2b1 would be equal to negative 4a. And then when I divide by a negative 2, I'll get a positive 2a. And then the beauty of this is we can substitute in these things and we'll have all of them in terms of a. So 2a minus 2 times a1. a1 was negative a. And then plus b1, and b1 was 2a, and that's equal to 6. So then, this is 2a, plus another 2a is 4a, plus another 2a is 6a. So we get 6a equals 6, so we'll get a is 1. Well, if a is 1, a1 will be negative 1, and b1 has to be 2 times 1, which is 2. And so, we will end up here with a, which was 1, and then a1 we said was negative 1, right? So plus negative x plus 2 all over x squared plus 2x plus 4. Good so far? Now this one's still going to be a little on the tricky side, okay? But let's do it. Here we go. We're going to have the integral of. So the very first one was just 1 over x minus 2. I'm going to split these integrals. Because like I said, the next one will be a little mean. First, I'm going to factor out the negative. When I factor out the negative, I'm going to be left with positive x minus 2 all over the quadratic x squared plus 2x plus 4 with respect to x. Cool so far? Now I want you to look at the second denominator. If I did a u substitution, do you see that my du would be 2x plus 2? So I want to generate a 2x plus 2 situation. So first I am going to multiply by 1/2 and by 2. It's not going to be ready to integrate, but we'll be one step closer. I'll go ahead and evaluate this integral, or find this indefinite integral, natural log at absolute x minus 2 for the first one, minus 1/2 times the integral of 2x minus 4 all over x squared plus 2x plus 4 with respect to x. Now remember how I wanted 2x plus 2? So in order to get a positive 2 there, I need to add and subtract the same amount, basically adding 0. So if I add 6 and subtract 6, when I add 6 to negative 4, I'll have the positive 2 I wanted. And then what I'll do is I'll rewrite it, that one, into 2 indefinite integrals. So we'll have minus 1/2 times the integral of 2x plus 2, so the negative 4 plus 6 part, over x squared plus 2x plus 4 with respect to x. And then I'm going to end up getting minus 6 times the integral of 1 over x squared plus 2x plus 4 with respect to x. Now for the first one, I've got it going on. I can complete that one. For the second one, I need to complete the square for it, right? So to complete the square, this is a great problem. It combines so many techniques. We start with our x squared plus 2x plus 4. Now don't forget about that 4 is equivalent to x squared plus 2x. I'm going to put the plus 4 a little bit aside from it. And then half of the coefficient of the x is 1. And if I square 1, I still have 1. So I'm adding 1. But I have to subtract 1 to balance it out, because I'm writing an equivalent expression. So I'll end up with x plus 1, the quantity squared, plus 3, which I could write as x plus 1, the quantity squared, plus the square root of 3 squared, which will be an arctangent result, won't it? Beautiful. So let's do it. We will have, carrying along our natural log x absolute x minus 2 minus 1/2 times, I've set up the other one so I'm ready for the integration. So I have natural log absolute x squared plus 2x plus 4, and then bringing that negative 1/2 to the 6, I'll have a positive 3, and this will be the integral of 1 over x plus 1, the quantity squared, plus root 3 squared, and then that's with respect to x. So simplifying the first two, I will have natural log of absolute x minus 2 over the square root of x squared plus 2x plus 4, and then plus 3 times, my a is root 3, so I'll have 1 over root 3 arctangent of x plus 1 over root 3. Now 3 over root 3, if you look at it off to the side, just FYI, if you rationalize, the denominator would be 3 root 3 over 3, which is just root 3. And so, last line will be equal to natural log absolute x minus 2 over the square root of x squared plus 2x plus 4, and then plus the square root of 3 times arctangent at x plus 1 over root 3 plus our constant of integration. And we're all done. Groovy? Now this is a multi-part video, so make sure you watched the warm-up and the other parts of the video. I think I had a part 1 and part 2 before this, and then I'll have a part 4 after this. So if you like what I'm doing, please hit that subscribe button, that like button, maybe share the video, and I hope you have a wonderful morning, afternoon, or evening whenever you're watching this show. Bye.